Thanks, Ingrid. As Ingrid said, we're going to talk about selecting the right asphalt mix today. No other engineering product provides such versatility as asphalt. It's used for a variety of different uses, from residential driveways, heavy interstate highways, airport runways, railroad underlayments, commercial, industrial, and recreational facilities. In order to ensure good performance, it's very important that we select the right mix. For example, here in this picture, we show a parking lot application. Well, we wouldn't want to use a high volume freeway mix on this parking lot, as it will not perform. So today we're going to kind of talk a little bit about the history of mix design and binders. We'll also talk about regression, recycled asphalt pavements, as well as get into some APAM mix recommendations. So mix history. We go back to the 70s. In the 70s, we used the 411 and 412 mixes. These were designed using the Marshall mix design methodology. These mixes were made and tested with certified aggregates and sand. Basically, MDOT tested and certified different aggregates and sand and told you how to proportion those and put together the mix design. In the 1980s, we moved into this, what we called the stability mixes. These were the alphabet mixes, A, B's, and C's. Again, these are Marshall mix design methodology. We started blending more multiple materials through the plant. We weren't just using one aggregate and one sand source. There were no specific gradation specs for each of the component aggregates. There were also no angularity index or sand on the sand. And basically, the final mix had to meet for gradation and asphalt content. MDOT was still doing the mix design here, so they were testing all the aggregates, putting the mix designs together, and they were being produced at the plant. The 1990s, we shifted into what we called the performance mixes. These were the A, B's, and C's. More crushed and angular materials, both fine and coarse aggregates, were being used. We added the Michigan angularity test for fine aggregates. So that gave us the angularity index. So producers started doing the mix design here, and we're blending multiple materials through the plant. And then MDOT would check those mix designs. If you were here for our last webinar last week, we talked about how the mix designs are produced and all that. Really, these performance mixes, we were kind of moving, MDOT was moving towards super pave. So we got into the super pave mixes in the 2000s. The first ones were actually done in 1997. And these are the E mixes. The big change between those Marshall performance mixes and the super pave mixes were the use of the gyratory compactor to compact the mix design specimens versus the Marshall hammer, which I'll talk a little bit more in detail. And we also incorporated the use of the performance graded binders. So those are the PG binders, which we'll talk about as well. Really, one of the big differences between the Marshall mix design methodology and the super pave mix design methodology is the Marshall really primarily was addressing determination of asphalt content, whereas the super pave methodology was addressing all of the different volumetric elements of the mix design. As I said, the gyratory compactor and the Marshall hammer were the two different ways of compacting the mix samples. If you're familiar with the Marshall hammer, it was basically a 10-pound weight falling straight down 18 inches, typically did 50 blows for the mix design. And so that versus the gyratory compactor is a machine. It imparts a rotational downward force, a certain number of gyrations based on traffic level. So in the slide here, there's ram pressure, 600 kilopascals, and you're rotating that. As you're pushing down, it rotates at an angle. And what this does is it mimics how compaction is done in the field and over time with traffic by kneading that material together. Um, and the idea was that that's going to give us a better idea of how that mix compacts than just a 10-pound weight falling straight down onto the mixture. So when we talk about the super pave mixes or the E mixes, um, there's two different designations basically around the E. So the number in front of the E. So for this example, 5EL, that 5 corresponds to the gradation. And basically, we have 2 mixes, 3 mixes, 4 mixes, and 5 mixes. So 2 mixes are your base mixes. 3 mixes can be used as a base or leveling. 4 is leveling and top, and 5 mix is typically just a top mix. And that corresponds to the gradation, as I said, and the size, like basically the top aggregate size of that mix. And then that corresponds to lift thicknesses. Um, So then we get to after the E on our super paved mixes. So there we have L through H. So we have EL, which is your low traffic. So that mixture type corresponds to the estimated traffic. So EL is low, EH would be high. There's basically 4 designations: EML, EMH in between. Next, we'll talk a little bit about the asphalt cement history. So back in the 1920s, we used penetration grades. Those were your 85 to 100, 120 to 150, and 200 to 300. Um, and then in the 1960s, they went to viscosity grades, your AC 2.5s, your AC 5, your AC 10s. I wasn't around during the 1920s. I don't remember the penetration grades. I do remember the viscosity grades. Um, and both of those, the pen grades and viscosity grades, they worked fine. They were empirical tests, basically run at a given temperatures, and basically telling us how soft that liquid asphalt is or how stiff it is at that certain temperature. Didn't provide a lot of information over entire range of temperatures. The PG binders or the performance graded binders came along in the mid 90s, kind of with the super pave methodology. And really, the performance graded binder specifications do a lot of testing over a lot of different temperature ranges, aging conditions, and all that. So the idea is that we're better quantifying how that liquid asphalt is going to perform during production, during placement, during the life of the pavement. Um, so, a lot more engineering went into that. So, talk a little bit about the super pave binder designation. A typical binder that we use is a PG 58 minus 28. So the PG obviously stands for performance grade. The 58, the first number is your average 7-day maximum pavement temperature, and that's in degrees Celsius. So 58 is 136 degrees Fahrenheit. And then the minus 28, it is a negative 28, is your minimum pavement temperature. So that's negative 28 degrees Celsius, which is a minus 18 degrees Fahrenheit. Next, I want to talk a little bit about what is regression.
Jack, I've got a question for you.
Yep.
Just with those, with
Back on the
the super
PG.
pave, yeah, with the super pave, the binder specification and just the super pave mixes in general, are those unique to Michigan, like the EL, or the PG 5828? Are those unique to Michigan, or are those universal?
Those are all pretty much universal. The EL is unique to Michigan. The original Super Pave were like E03, E1. There were a whole bunch of them: E10, E30, E50. There were originally 7 different traffic designations. A lot of the states over the years have combined some of those to kind of simplify things. A lot of them went to like a low, medium, high volume. Some of them went down to 2. Michigan was one of the last states that was still using all 7 designations. So in an attempt to try to reduce the number of mixes that we're producing here in the state, we originally wanted to try to go down to 3, low, medium, and high volume. MDOT kind of wanted to keep the 4 of them, so that's where we ended up with. In some ways, it really is kind of like 3. The EH doesn't get used that often here in Michigan, because when we get up to those higher designations, a lot of times MDOT will specify an SMA mix, a stone matrix asphalt mix. So we feel like that we've gotten down. But as far as the binders go, the 58 minus 28, the 64 minus 22s, those are the same for all the states as far as the different designations. And it really depends on what climate you have and how many different binders might be used in your state. A lot of the states that have a lot of area from north to south, they'll use more multiple binders throughout their state. Some states will use the same binder throughout their state. Good question. So next, I'm going to talk a little bit about what is regression. So when we design an asphalt mix, we want to make sure that it's designed to be stable, durable, impermeable, and workable. We've got to be able to place that mix. And we do this basically through material selection and volumetric design. So what aggregates are we using and how are those aggregates put together and held together with that liquid asphalt through our mix design process. So mix design is really a balance between strength and durability. We can design a mix that will be highly rut resistant, but it may not be durable. And when I talk about durable, I mean, resistance to cracking. Or we can design a very durable mix, but it may be prone to rutting. So the key is to balance the various constituents so produce the best mix that will resist both rutting and be durable and last for a lot of years. And really, asphalt content is this balancer between strength and durability, or rutting versus cracking or raveling. Too much liquid and it can rut, or too little and it can crack. The reason we like to talk about what is regression is here in Michigan, the initial super pave mixes, we really eliminated rutting on MDOT roads. That was kind of the major um, deterioration for the old Marshall mixes was rutting. So when we moved to the super pave, we really got rid of the rutting, but we found out that we have a durability issue. Some of the early super pave mixes were, prone to cracking and raveling. So as we reviewed the specifications and that, we decided that we really need to do some changes to get more liquid asphalt in these mixes. It's kind of like we called them the dry mixes. So really in 2012, we regressed air voids from 4% down to 3.5%. That resulted in adding a couple tenths of a percent of liquid asphalt into those mixes. And then by 2014, we thought, well, let's take the next step and go all the way to 3% air voids because it seemed like we were getting better durability, seeing less cracking. And then in January of 2015, we also decided to require fine graded mixes. So when you design a mix, you have your gradation line where you're either coarse graded or fine graded. So we wanted to make sure, force all the designs to go to fine graded mixes for all your top and leveling courses. Finer the mixes are, the more liquid asphalt it takes to coat those aggregates. So really that's what we wanted to do to increase the liquid asphalt content in our mixes and make them more durable. So what exactly is regression? Really, regression is a way to improve the durability of your mixes. So most mix designs, any super pave mix designs are done at 4% air voids. That's where you design the mix to meet all your volumetrics and that. And then once we have that mix design, how much liquid asphalt do we want to add to that to achieve that 3% air void determination? So this is an example of how we do the regression. Um, for those of you that were on the mixed design, you remember the 4-point design. So we've got air voids versus our 4 different uh, asphalt cement contents. So our optimum at 4% in this example is 5.7% liquid asphalt. So we just regress that by looking at, okay, I go down to the 3% air voids and my asphalt content should be 6.1%. So we've added about 0.4% in this example. So that's what we're doing is with regression, is getting more liquid asphalt, closing up those air voids in that mixed design. So next I want to talk a little bit about wrap. Why do we want to recycle wrap into mixes? Really, it's its best and highest use. You can see the same or better performance as virgin mixes. We're gonna recycling, reduces the demand for new materials, reduces our carbon footprint, and it really contains valuable materials. People like to use wrap for like gravel applications and that, but you're really not getting um, using that for its best and highest use because you're not reusing that liquid asphalt in your new mix. Um, let's see. Yeah, and asphalt pavement is the most recycled material in the world. It's estimated that we save over $2 billion of the taxpayers' money each year. So, and I kind of covered all the best and highest use, all this stuff. So, want to get into it a little bit of a example of how much money we can save. Um, if we look at aggregate about 20 bucks a ton, asphalt cement at 600 bucks a ton, that value of our wrap is about 55 bucks a ton. I like to tell a lot of people that's probably more than we spent to place that asphalt that we're milling up and reusing into our new mixes. So it's really a great return on investment. You had a
Can wrap
question, Ingrid?
Yeah, can wrap be used in the top course?
Yes. Yep. Yeah, wrap can be used in any course, and I'm going to talk about kind of the best practices on how to use wrap here in a minute.
All
Um,
right.
yeah, because
We've
there's
got a few other questions,
specifications
but we'll hold those ones till the end.
on
We'll let you
wrap.
keep going.
Okay, there's usually a lot of questions on those. So here's an example of the cost savings that we can see with using wrap. Um, again, using those same numbers and $10 a ton for processing the wrap, we're looking at 15 to 23% savings if we, get to the tier 1 and tier 2, what we call it, based on the MDOT specification, 17% binder replacement and 27% binder replacement. So recommended best practices, really processing and management of the wrap. As we're processing the wrap, we got to sample and test that. Um, excuse me. You got to have a wrap usage specification. So wrap mixes, if we're incorporating wrap into our mix, it's got to meet the same specs. And then we need to adjust our binder grade appropriately. And it's very important that you have an approved mix design that includes the wrap. So that the mix design that includes the wrap, you've got to know those properties. You got to know the gradation of the wrap, the binder content, and the theoretical maximum specific gravity. By the MDOT requirements, producers have to sample and test their wrap, 1 sample per every 1,000 tons of processed wrap. So you got to do that as you're putting together your mix designs. That way you know what's going into it. And then you've got to have the mix design incorporating that wrap and taking into account all of those wrap characteristics. So mix design example here, we've got 15% wrap going in. Our total asphalt cement is 5.7. We got 5.16% new AC added. So we're accounting for a little bit of that asphalt cement coming from the wrap. So really, we want to make sure that we're testing the produced mix that has wrap in it, just like we would all of our mixes. The contractor's doing quality control tests, the owner's doing quality assurance and acceptance tests. Um, if you have any performance concerns, we've heard over the years, people don't, trust that the wrap mixes are performing as well as the virgin mixes. We've even seen some people, specking no wrap in their mixes. Really, maybe then you should consider testing or monitoring other properties, mix volumetrics, fines to effective binder ratio, different things like that. I think wrap got a bad rap, so to speak, when, maybe people weren't really testing the mix. They didn't really know what was going into their mixes, and maybe they had a bad performance and blamed it on the wrap. So. Do we want to take any of the other questions on the wrap, Ingrid, before I move along to mix recommendations?
No, let's keep going and then we'll
Okay.
go through all the questions at the end.
Yeah. Okay. Yeah. Just a few more minutes here. I've only got a few more slides. So, just quickly, I want to talk a little bit about mix recommendations. And really, APAM suggests avoiding the use of 13A or LVSP mixes as top courses. Really, appearance isn't a specified item, but it can become a problem when the mix looks bad. And the problem with 13A and LVSP mixes is they can be, the gradation band is very wide on them. They can be coarse graded at times, and they're not a pretty looking mix. There's nothing wrong with the mixes. They can perform just fine, but they don't always look the best because there's a lot of larger stone in them and they can look almost segregated in times. Another issue with them is a lot of people will specify them as a top course mix and try to place them at 1.5 inch thickness when they should really be 2 inches minimum thickness. So then you're dragging rock and having problems really getting them compacted. So we just recommend getting away from using those, especially as a top course mix. Really, we would suggest using a 5E super pave mix as a top course. They're fine graded, they're regressed down to 3% air voids. They're going to be very durable. They're going to look nice. They're nice and smooth. And we feel like everybody's going to be happy then if you're just specifying 5E mixes on top. Like I said, they're regressed to 3%. You want to obviously select the one appropriate mix for your traffic level. Low volume road, a 5EL. If you've got higher truck traffic areas or commercial roads where you got high traffic, you want to look at using a 5EML or 5EMH. Layer thickness between 1.5 inches and 2 inches. Make sure we're getting that mix properly compacted. Really, consistency is important. Too many mixes in the same operating area of the state can cause problems. If you have one plant that has to make 10 different 5EL mixes because some people are tweaking the mixes or anything like that, that can become an issue. You really want to avoid small quantities of a single mix or small quantities of specialty binders. This gets into, pavement design and how do you best optimize your mixes that you are specifying. Be very beneficial in cost savings if people in an operating area can agree to use one type of mix, then the contractor's making that mix all the time. There could be a lot of cost savings due to efficiency of operations there. So really, less is more. Less mixed designs, less yard space, less variability, less cost. Really, that gets you more streamlined, more efficient. Like I said, asphalt plants are producing mixtures at 200, 300, 400 tons an hour. They don't have a button that you just push and all of a sudden it's making a different type of mix. There's some time lag in there before that all takes place. You're wasting some mix every time you switch mixes. So if we can all specify the same mixes, it makes the plant operation more streamlined, more efficient. It also makes it more consistent. If you're using the same aggregates, same proportions, and you're running that all the time, you're gonna be a lot more consistent, so you're gonna have better quality, and really, with that less cost, better quality, we're gonna get more lane miles paved and do a better job for the taxpayers. So with that, I know it's kind of quick. Usually take a little longer to go through this presentation, but we cut her down. So we'll be happy to take any questions now. I'm sure there'll be some.
All right. Yeah, we do have a few questions. I just want to let folks know I did drop the survey for your certificate of attendance and the evaluation into the chat. Um, it's a Survey Monkey link that will be open for about 24 hours for you to take. I recommend you jump in there right now in case you have any problems using the link. There is a question in there that asks if you're attending with a group of people. If you are attending with a group of people, it lets you get a certificate for all of you in one, only one person has to do the survey. You just put in all the names. If you're attending by yourself, you have to put a 0 in when it asks you how many other people are attending with you, or else it will not let you continue on with the rest of the survey. So go ahead and do that. So you can jump in that survey. We do have some questions here. We'll stick around and ask those of Chuck. So we've got several questions here that are kind of about traffic and the selecting kind of the right mix for your traffic, right?
Mhm.
So one of the questions was says sometimes we see 4 EML or 5 EML, and is this the same as 4 EL or 5 EL? Which it's not, but what are like the bins? How big of a jump is it when you go to that next
Yeah,
bump up?
yeah. The low volume, if you remember the old designations, so the EL mixes are basically anything up to 300,000 easels, if you're talking about a 20-year design. So basically, we took the LVSP and the EO3 mixes and combined them together, and that's our low volume mix. Um, and then you go up to the EML, and that was your E1s and E3s. So up to basically from like 300,000 easels up to 1 1,000,000 easels, or no, 3,000,000 easels, yeah, E1s, E3s. And then your EMH was your E10 and E30, so that's your up to 30,000,000 easels. Then EH is 50,000,000 easels and above. So, yeah, it's all based on traffic, commercial traffic. For a lot of local roads in that, MDOT specifies, mix selection based on your commercial ADT rather than easels and that, just to make it easier. Especially if you're not doing a full blown pavement design where you figure out those design easels. So
Okay.
there are
So
differences. It's kind of my example on like a parking lot. You're gonna wanna use a low volume mix because you don't have a lot of traffic going over it. So if you use like an MH mix on there, it's basically gonna crack really easy. So the it's not gonna have enough liquid asphalt because as you go to the higher volume mixes, there's less asphalt in them, because you're relying on that commercial traffic going over it to, I like to tell people, you're keeping that flexible pavement alive because it's flexing. And that, so you don't need as much liquid asphalt in there because it's moving around and keeping it alive. Where your lower volume, you don't have that traffic on it. So it's basically sitting out there in the environment. So you got hot days, cold days, baking in the sun, it's drying out that top layer. That's the best way to think about it.
okay. Speaking of parking lots, we do have a question about parking lots, which was if you're paving a parking lot or a small road patch, is it best to do what mix should you use? Which I think we just answered, but for both lifts, would you be using the same mix for both lifts?
Yeah, I would say whenever you can, use both, especially for patching and stuff. Typically, we'll say use whatever, like if you're doing a bunch of patching on a job where you've got a bunch of mix, use that same mix. Um, but yeah, if you're just out there doing small patches, it's not like the plant's gonna make you 5 tons of a 3 EL and 5 tons of a 5 EL. Just go get 10 tons of a 5 EL and or whatever they're making for the day, as long as it's not like something crazy that's not gonna work there. But usually patching in that will say, you want a top course type mix, because it's gonna usually when we're patching, especially smaller areas, we don't have the best chance to get good density on it and things like that. That gets into the whole another discussion on how we should do patching and stuff. But
All right. I think that also kind of leads into another question here that was asking about economics in terms of if you've got the same road, same traffic load, and you're trying to decide between mixes, what is going to be the most economical, which is probably what's going to be available to you is going to be the most economical. Is there some other factors in there?
yeah, I mean, there's a lot of factors that go into that. The big point of our less is more is we think it's going to be more economical for people if they're specifying the same mixes in an area. We've talked a lot about this for the last few years, trying to get people to, hey, if my neighbor's got a job over here that's buttoned up to mine, doesn't make any sense for if he's using a 5 EL, then I'm going to use a 4 EL that's limiting wrap and all the, these differences. If we could just agree to, hey, let's all use the same mix, then the asphalt producers in the area are making the same mix day in and day out. There's economies of scale there. Just like when a 50,000 ton job, you're usually getting a better price than a 5,000 ton job. Um, so that's the idea there is if we can all kind of try to consolidate what mixes we're specifying.
All right.
Don't over design things, I guess.
So here's a question about wrap, and I'm hoping that I'm going to ask this correctly. If it was your question, you can jump in here. So what about wrap that might not be that old? How is that? What is that providing? If it's you're taking a road that maybe hasn't gone through its entire life, and that recycled asphalt is maybe a little bit newer versus something that's really old. What are the differences, and what can you expect?
So that's why it's that's why it's important that as you're processing the wrap, because usually what happens, how we get a wrap pile is we mill up a existing road and bring it back to the plant, throw it in a pile, and then we process that wrap. So then we're crushing it down to different sizes, so that we can better incorporate it into the new mix designs. So that's where it's very important that we're testing that material that's been processed before we put it into the mix, so we can characterize it. Because different wrap piles are going to have different asphalt contents. They're going to have all of the different gradations, all that stuff, different densities, and all that stuff factors into when we're testing that mix to see if it's going to meet specification. So
So
typically you would think, if you've got a bunch of material that's, relatively new or a bunch of waste material or something, the liquid from that's going to be softer and probably more of it than an old dried up pavement that's 40 years old that's been out there.
all right. So speaking of other kind of add-ins, mix-ins kinds of things. So somebody asked about recycled glass being used here in Michigan, if that has happened, which I know it has in the UP. I don't know about other spots around. But how about if you are considering, one of these mixes that has some unusual materials? What can go into that kind of a selection?
Yeah. Yeah. And a lot of different recycled materials and different things have been tried out, put in. I mean, glass was tried out years and years ago. There's another push recently to try it again. You really have to be able to characterize the material, and then how is that going to affect my mix design? So I know years ago they tried using these glass beads, and that had some issues where the mix wasn't very stable. So then I think they tried some more crushed material type things, and you can try that. And then you really got, it's a lot of trial and error. It's kind of going through that mix design process. How do I characterize this? How is it going to react? How is is the liquid asphalt going to stick to it? How is it going to incorporate into the mix? There's all these questions. And that's why, during that mix design process, it's iterative testing. So you're trying things out to see how that's going to affect.
So that you're still balancing that flex versus strength
Yes.
as you go through. So question about the easels. Is that for selecting your mix, is that based on um, the total easels over the design life, or is it per year? How are we figuring out our easels?
Yeah, those examples I was saying, up to 1,000,000 or up to 30,000,000, that's over a 20-year design period. So it's basically like the ASHTO method of pavement design. So you're typically designing for that 20-year period. Um, so it'd be cumulative easels over that time period.
All right. I don't know that we have any more questions, but Chuck has agreed to stick around here for a little bit more time. So if you do have other questions, you can drop them in the chat or into the Q&A, and we will go through them. We do have our last lunch and learn here for this series is next Monday. So same time, same place next Monday. And that's going to be about asphalt pavement inspection basics. So we hope that you'll join us for that one as well. And if you have some questions, you can submit those questions in the evaluation, which should still be in the chat for you if you haven't found that yet. But I would like to say thanks, Chuck, for attending and giving this talk again. We really do appreciate it, and I hope that folks got a lot out of today's webinar.
Yeah, thanks, Ingrid. It's been great. I've enjoyed doing these. Like I said, this asphalt mix section, like many of the topics we've hit on these short webinars, we can really go into more detail if people are interested. I do presentations that last a lot longer than this, and we do get to delve into a little more detail on all these things. But we just kind of want to whet people's appetite and see what people are interested in as we develop things into the future. So, yeah.
Excellent.
Great.
Yes. Yeah. If you've got other topics that you'd like Chuck to talk about or other folks to talk about, we're happy to hear about them, and we'll try and make them happen. Oh, here's the question. What would you recommend for like a shared use pathway or for an overlay for the multi-use trail, that kind of a thing? Is there a mixed design that would be good for that kind of an application?
Yeah, it really depends on what types of uses. I know that, a general mixed use pathway where it's walkers and bikers and that, I would say a 5EL mix, low volume mix, that because really it's not going to fail because of traffic on it. It's like a parking lot where it's going to just, basically bake in the sun over it.
Yeah.
But there have been specialty mixes made for certain shared use paths, like if you're looking at horse traffic or snowmobile traffic. There's a spec out there for what we call a snowmobile mix, and basically it's a polymerized, 5EL type mix. It's got a lot of asphalt content, but you use a polymer modified liquid asphalt to stand up to, studs and metal horse hoofs and things like that a little better.
All right. This is a question, a good one. Does each type of mix have its own compaction rate and temperature specs? Does it change mix to mix?
Yes. Yep. And we kind of covered that a little bit on the mix design thing, but every mix design and it really comes down to the liquid asphalt that you're using. So each liquid asphalt has a certain mixing temperature range, and that's your maximum mixing temperature that you want to see. And then it also has a maximum compaction range as well, temperature listed right on the mix design itself. So those numbers are available out there.
And then here's a question. This one almost goes more into next week's, but what's a maximum depth for a milling machine per pass? And are you worried about that in terms of mixing in wrap that might be, how you're selecting your wrap, how maybe mixing in some of that base course as opposed to getting just only wrap? Are we concerned about that, or what are some thoughts on that?
Yeah, really. I mean, some milling machines can be made, they can mill up to 12 inches deep. you get into the machines that are used for like full depth reclamation and stuff like that, they can go deeper and they are made to kind of blend in some of that stuff. But it really depends on speed, teeth spacing, all that stuff. I mean, as far as your maximum depth. A lot of that goes into if you're worried about what else you might be milling up and things like that, a lot of that goes into knowing what you have out there and what your project entails. If I'm going out there and I think I've got 3 inches of asphalt out there and I'm going to mill off an inch and a half and repave an inch and a half, then you wouldn't expect to hit anything else like aggregate base or anything like that. But sometimes you do. There might be some soft areas or something that as you paved it originally, maybe it didn't get that 3 inches thick because it moved around. And I've seen a lot of residential roadways that in fact mine out in front of my house they did a few years ago, and they were supposed to be 3 inches and they milled an inch and a half, and they were hitting gravel in a lot of areas which were the areas that were all cracked up for some reason. So
Weird.
yeah.
All right. Yeah. How about this one? Are there certain mixes that might perform better in colder weather, like UP snow? Or I know we've got somebody in the, I don't know if they're still here, but they were from Alberta. So are there some mixes that perform better in cold weather?
Yeah, I think, the cold weather really goes down to when we're selecting the polymer modified or the performance graded binder. So that second number, the -28, that's a typical binder that we'd use basically for the lower peninsula here in Michigan. Up in the UP, we use a -34. So that number equates to what we call cold temperature protection. So it's based on, that coldest weather that you're expecting to see over that 20-year pavement life. And what will happen if a temperature exceeds that over that life is you get low temperature cracking. So you'll get regularly spaced transverse cracks on your pavement. So that's really, it's not some people in the colder weather climates, depending on how you deal with snow removal or salting or sanding, things like that. Some people have gone to using like a 4 mix as a top mix because it might not be as smooth as a 5 mix. So you get a little bit more macro texture on the pavement, and that can help deal with, more icing and things like that, give you better traction. So there's a lot of factors that go into that, but I would say, sometimes in cold weather climates, you could look at doing something like that too. I just caution that you go to a 4 mix and then you should be placing it at 2 inches minimum thickness in order to properly compact that mixture. So
Our Alberta attendee says that they use 58 -37 and 58 -28, depending on which part of Alberta they are in. So
yeah.
thank you for that.
Yes.
Um, this is a question I don't know that you will have the answer for this one. This is a question about for those paved trails that you might have, or even sometimes not paved trails, sometimes very low volume paved roads. You can get some weeds that start to penetrate coming up through the cracks and that. Is there anything that you shouldn't be using to kill those weeds? I'm guessing
Well,
that is more of a chemical reaction between your asphalt binder and your, Roundup or otherwise materials.
yeah, I mean, the best way to deal with them is not have them in the first place and
Yes.
actually build a base underneath your asphalt. But I know a lot of trails, they just kind of peel off the grass and pave, but there's no protection of those weeds and tree stumps and yeah, roots popping up through. So as far as, things to spray on it, asphalt's pretty durable. Asphalt mixtures, I mean, you wouldn't about the yeah, there are certain chemical reactions that can happen that will, like diesel fuel. You drop diesel fuel, or, any most types of fuel type things in the asphalt will start to disintegrate. I don't know if there are off the top of my head if there are any like weed killers that will do much harm to an asphalt pavement. So I guess that would be the best thing to do is just kill them that way. But
This is a question I think
ultimately, we wouldn't build them that way.
right. That's a starting off strong. Don't
Yes,
don't do
yes.
it. Set yourself up for hardship later. This is a question, I think we've gotten it before. Is there any impact on road salt on asphalt?
No, that's more of an issue with certain types of road salt or concrete pavements.
Yeah.
Yeah, and that's a chemical reaction with the lime and all that stuff.
Yes, we avoid that with asphalt. How about, can you clarify when you would recommend going with a 2-inch versus a 1.5-inch on your leveling course?
It depends on what mix you're specifying. I mean, if you're using a 5, because can't stress enough how important compaction is. And based on the nominal maximum aggregate size of your mix, there's a certain range of thicknesses that we can properly compact that mix. So, if you want to do an inch and a half leveling mix, you should really be using a 5 mix. You get into a 4 mix, and you should minimum lift thickness of a 4-inch should be 2 inches. And that's so that we can make sure that we properly compact that mix. We usually always talk about minimum lift thicknesses, but there is also a maximum lift thickness range as well. And that usually gets more into when we're paving base courses and things like that. But for most 2-course overlays and things, people are concerned about how thick does that leveling course have to be. And really, it depended on what mix you're using.
All right. I don't know. We don't have any others, but we can stick around here for a little bit longer. So check for our asphalt inspection basics next week. Do we have any sneak peek on that one in terms of what all we're going to be talking about?
I think that, the big thing about asphalt inspection basics is it's good for everybody to know what some of the best practices are and things to look for, because really in the end we're all a team. From the contractor who's laying the asphalt down to the inspector who's out there and making sure that they're doing everything right. Designers, it's good for them to know, what those best practices are so that they can kind of think through some of that stuff, hopefully, while they're putting plans together to make the job go smoothly. So it's really a whole team approach. I'll say that's my sneak peek.
And I guess we have a clarification on your last answer. So for a 4 mix, you'd want a minimum of 2 inches. Is that like a good rule of thumb?
Yes. Yep.
All right. I think that might be the end of things. We'll give you another couple minutes here. And if you haven't gotten the survey link to grab that, I'll drop that in the chat here one last time for you guys. Oh, this is a good question. How many times can you recycle the wrap? So you've used wrap in your mix. Can you then make wrap out of that mix and then make wrap out of that next one and so on?
Yes. Theoretically, indefinitely. Now, obviously, as that wrap continues to age, and that's why we got to test that wrap that we're using to see how we can characterize that, because it should start to degrade. You're going to have less asphalt content. It's going to be a little stiffer each time you do that. Um, so, but you should be able to still recycle that mix into the new mix. It may just be how you characterize that and account for the wrap in your mix. Maybe we got to add a little bit more virgin asphalt because the asphalt content's a little lower as you go.
That makes sense. I think that might be our last question for today. Thanks so much, Chuck. Thanks for everybody who attended. That link is in the chat. We'll give you another couple of seconds to grab that. We do have a question about these are recorded and the recordings will be sent out to you along with the slides. So you can look for that in your email. And other than that, thanks again, Chuck, so much. We'll talk to you again in a week.
All right. Thanks, Ingrid. Everybody have a great day.
Thanks, everyone. We'll see you next week. Bye.